So here actually unit number 5 is talking about data store, the databases in the background, and also the cloud computing approaches. So here actually the databases and the concern of the background security is one of the concerns that we have to tackle. What we're going to see in this unit is the not the definition of the database, but the concerns of the security versus the database. It means whatever a good approach or a good let's say, behavior to be done by actually a system owner to secure the data store, to secure vulnerability that the data store presents, to enhance the service delivery, and so on. So this is the concern of this chapter. We're not going to build the databases. Immediately, the first actually approach to discuss this regarding the physical architecture that a database can be seen through. The physical architecture here we mean by that the way how the database can be utilized, the way how the requests can be submitted to the database, and the way how the response can be retrieved from a database. What we see in front of us is a graph via which we are seeing the database completely in behind of all the let's say layers where the application processes run. Here we are seeing other layers where we see the database, but in all cases, there's a chance to directly to give us the chance to directly interrogate a database, but this is not the final view. What we can see here is an interface via which we see a user-friendly interface where requests can be submitted, or where we can see actually responses sent by the database in response. An intermediary layers, which is actually the management of processes, the management of the processes, or let's say the management of the requests sent by users. Other layers to direct the responses and the requests from the users to the database, and from the database to the users interface, and so on. So it is the role of those layers here. This is actually it is a common understanding here. It is not a technical approach, but what the technical describes to us is that database, they are to be seen through layers. This first security is a physical security, and this physical security, it is a concern of the system developer, the system owner, the application, let's say, developer again. It is an approach via which we segregate the database from the front end interfaces. Whenever it is far away from the end user, whenever the data actually it is more secure. Whenever we say that the database is not visible, whenever we can say that the security is high. So we are not able and we cannot finalize the number of the layers to be seen between the front-end interfaces and the back-end data engines. Why? Because as many as a project requires layers, so we can interrogate. I can give you the example actually of the SQL Server, which is from the Microsoft. The SQL Server is one of the very famous database, the professional database engines, database management systems. And to utilize it, we need an API, a specific API, like the Visual Studio or the system, let's say, data tool, the SSDT, or the system, the SQL Server Management Studio, and through which we can link and use the database. So this is a two-layer, a two-tier application, two-tier design, two-tier architecture. In another scenarios, we can refer to a very remote, let's say, a very long path, remotely accessing database engine, which requires n tiers in between. So, in conclusion, the physical architecture is the segregation of the front-end applications or front-end interfaces from the backend data store, which is a database, and as many layers as we can generate, as many as the security is enhanced. And in the same regard, in certain many layers that they actually separate the segregate the front end interfaces from the data store, does not mean that we are just securing. We are causing a latency at the same time. So there is a drawback of the physical architecture. It is an enhancement sent to the security. Yes, yes, but it is a time-consuming process because a layer means a filter. So a filter needs a time. And whenever we add another filter, so there is a time to be consumed again and again and again. The first definition that we are going to go beyond defining the database is actually that it is related to security only is the relational approach. Database, they are numerous and seen respectively actually uh, with different architectures, different approaches, different let's say they are seen within different frameworks and so on. So the relational database, they are sort of correlating data in order to make actually consistency in between the entities within the same database and let's say database system, database engine, or something, database based project. Uh, it is a way via which we correlate and we link the columns and the rows to be consistent. It is a sort of relating entities all together, also to be consistent, to answer different questions and to generate constraints via which we cannot update an entity without the reference and so on. So we are making restrictions, a sort of restrictions at the end of the day, whenever we discuss the relational database as per the security view or discussing the security wise. So what the relational presentations mean for database security, it is a draw of links and restrictions. Draw of links and mainly restrictions. To restrict, secure, absolutely. To restrict means to secure. Relational database. So at the end of the day, still the relational view is the same. We are correlating and we are linking entities all together to build a consistent view. Uh, For the definition, you have to know a table. Actually, a record, it is a particular object. A field, it is a particular list of similar values. Um, and the relationship, it is to link values together. Means we cannot link a record to a record. We link a field to a field in relational, let's say, view or constraint to be built behind the relational databases is to link a field to a field. Example of, let's say, database, relational database, whatever the entities, the number of the entities, there have to be a map. There have to be a map, a model via which we can see the entities correlated and linked together. See the arrows, the directions of the arrows. They are both sides. Means we can go from the unit, the entity number one to the entity number two, then from the entity number two to the entity number four, then the entity number two again, then the entity number whatever. We can move. What is the thing to be moved? The electricity. Whenever we need any information related to this entity, we can search it. There have to be actually a path, a channel. There have to be a relationship. Means from this entity, is there any representation here? Yes. And from this entity, is any representation here? Yes. This is the fact of the relational representation. Okay, exactly what we were discussing concerning the relational database. Still, we are talking about the relational database views only. It's a matter of a table at the end of the day. We have records and we have fields. Records, it's a list of objects. Fields, they are values, and they are going to be represented as attributes later on. Okay, here we are seeing a clear representation of the relational database. We are having a department, and we are having an employee, and then after we are having an association table, something like that. So here we see the EID, the field EID is represented here in the employee ID as a primary key. Primary key. This primary key is linked here, is represented here to be foreign key here. The ID, it is to be foreign key if it is in another entity. Sorry, in another entity. But without the primary key, we do not talk about the this entity here. If it is deprived from any relation, so it can be seen a standalone entity here. But here, if it is in a relational database, there have to be a relationship with the other entities. In this example, we are seeing the DID here. The DID is represented from this entity, from the department table here. So the DID here, it represents this entity here. This is a foreign key. Foreign key. Why? Because it is originally in its table, it is a primary key. And this is due to the relational architecture. DDL representation here, actually, I come back just one step further, one step back, sorry, a little bit. Yeah, the DDL here, the data definition language, the DDL, we are seeing it here in this view here, creating, sorry, creating here table number one, creating table number two, and create a view. So we are creating objects to be generated inside the database. Those entities or those objects, the view or the tables, they are created using specific SQL queries. And those SQL queries here, they are classified as DDL data definition language because they are defining the structure, the architecture of the entities inside, the fields, their data types, and so on. Okay, one step further here to discuss security now. We presented the first concern of this chapter. We presented the relational databases and we defined that and we discussed why we are seeing them security wise. What do they actually mean to us as cybersecurity agents? The relational databases. Now let's talk about the issues versus the databases themselves, and we'll talk about the countermeasures later on. The SQL injection, the structured query language injection, is one of the very famous, not only famous, it's very famous, let's say, database attacks, which is actually tackling the objects inside using regular SQL queries. What it uses regular SQL queries, and because of this, it is very dangerous. Attacking a database with what it understands is very dangerous. Why? Because the database will respond. Yes, if you speak to me in my language, I will understand you. This is what the SQL injection does. It speaks to the database with its language, which is the SQL. So the database will understand. SQL injection. It is very dangerous. Why? Because it's very successful. The database, if they are interrogated using SQL, they will reply absolutely true. So this is very dangerous behavior because the SQL Injection, it is to interrogate the database, yes, with the SQL, yes, but with sending malicious commands. Sending malicious commands to let's say um, to expose data, to delete data, to alter data, to hide data, to encrypt data, and so on. It is to pass SQL commands, yes, but it is malicious commands, and they are to expose the data or to do something more severe than exposing the data. Yeah, so all what we described earlier, it is valid for this SQL injection as an impact, if successful. If successful. So there will be a malicious behavior happening inside the database using simple SQL. Using simple SQL. Oh, what does mean simple? It's not a matter of easy or complex. No, no, no. It's using the SQL itself. It's using the language of the database to understand. It is not a concern of easiness or hardness. No, but it is something that the database do understand. Absolutely true. Absolutely true. A way via which we see actually the database actually being interrogated. In here, we are able to see a path from which a user is just reaching the database. See the green line here, the green line here. It is following a certain path. It's not unique because it might go through here, then here, then here. But it's on this path. Actually, this is one of the paths that the, let's say, query goes through in order to reach the database. Here we are seeing layers. Layer number one. In the internet, there might be so many layers: router, firewall, switch, and so on. Server number one here, server number two here, and the database server number three. So we have n layers, 4 or 5 in this graph. But when considering the internet relays, there will be n layers, then n tiers, as many as the hops are available. It is in both directions, means the user to the database and database to the front-end solution. A very famous, actually, syntax via which we are going to interrogate a database to check if username is correct or not. Log in using the username and the password might be in background holding a query similar to this one here. We are going to retrieve, come on, we're going to retrieve here the first name from the table students, and this to be retrieved if where clause the first name, the same first name, is here what the user has input the text box. What is the problem here actually in this portion only? Let me just exit. What is the problem in this block only here? What is the problem? The problem is that what the user would actually prompt here, what the user would input here, what I'm gonna type, for example, in my case, Murad. So in my case, I'm gonna type Murad. Okay, what's the problem? The problem is that if I type like so, here I'm gonna type Murad, my username. Okay, immediately single quotation, semicolon, space this command until this single quotation drop table course. Then after the semicolon, hyphen, hyphen, 2 hyphens. Who can explain this query, please? I'll give 2 marks on the final if you explain clearly what does this query do. 2 marks in the final. Great, great. So no explanations. That's good. So here actually we are going to type Murad and single quotation. Why? Because the computer will read this Murad, put it here. Right after what actually this means, the user will type the full statement here. See, this one I'm going to replace it here. I'm going to replace it here. What does it mean? It means that, yes, that the computer will read Murad, then here it is closed, then semicolon means the statement what comes before has been finished. Here it is, finished. This is the second statement. What is it? A drop table cost. It would drop. It would drop the table completely. It would drop the table cost. It will drop the table. Then some minus minus. What is the minus minus? All what it comes after. All what it comes after is a command. What is it? What comes after? This quotation and this semicolon. The computer will not cause an error. The computer will not cause an error because of this quotation. It has to be closed. No, here using this command indicator, the computer will understand that this is command, so it's not error. It will not prompt any error here. It will continue. It will continue running as per the request, but before of that, it will delete. It will drop the table calls here. So here we see the issue. Here we see the danger of interrogating a database using the SQL in an input point where the input is there where there is no input validation. So such a behavior, the input validation is a must. The input validation is a must. Any questions in this regard, please? Regarding this example of SQL injection, it's not the first time actually we see it. But even though, if you have any questions, if you have any doubts, you may ask. So I come back. Yeah, so let's continue. Another example, which is the tautology here. The tautology. It's another example of a SQL injection. It's another example of SQL injection. Actually, I was expecting to get a question from you. How the user did recognize that he has to type single quotation, not a double quotation? Did he see from the you as a student when you use the ED Wave to log in, you have to type your username and password? Do you see such a query here in the front interface? Do you know that the system admin is using a single quotation or a double quotation? No, absolutely no. It's not visible. It's a server side. The query is a server side. Yet this is a matter of a guess. This is a matter of a guess to pass single quotation. If it succeeds, okay. Otherwise, the user would use not a single quotation. He will use a double quotation instead. So it is a matter of a guess. The tautology here, actually, the attack, the SQL injection here, the tautology, what the tautology does is not a matter of guessing the username and dropping a table just here to send a malicious command. This drop a table is a malicious command. It will drop all the thing inside the table cause. It is not good, so it is a malicious behavior. Great. The tautology, it is not a matter of deleting or dropping, but it is a matter of breaking the security level. So we saw this example so many times. The 1 equal to 1 attack. The 1 equal to 1 attack. 1 is usually equal to 1. So is there any by chance to find an error when testing? If 1 is equal to 1? Absolutely no. Usually it is true. Usually it is true. So instead of typing umbrella and things like that, the query at the end of the day would be receiving a value, something like that, a value, and then after it will continue the same way here, the same way here. So instead of typing this username here, no, the user will type single quotation space or 1 equal 1 semicolon command, the same way. This is the first example, and this is the second example now. So here we are closing the quotation, we are for sure, and we are telling the system or either this, which is the nothing, the empty, or equal to 1, 1 equal to 1. This is usually true. So the system will validate. Here we have a semicolon. We do not have it here like in this example. The semicolon here is here at the end only. So the tautology here will cause the system to see this true, let's say, comparison value to validate. So it will retrieve all the data here. 1 is equal to 1 is usually true. So for all records, the computer will act. Tautology. Remember that. And also here just I execute the thing. Semicolon minus y. This is to terminate the statement, and minus y to indicate that all what it comes after is a command. This is a command only. So the system will not cause an error telling you what is this quotation, what is this semicolon. No, they are command. So you will leave them. Great. Tautology. There are other techniques via which attackers might refer to the SQL injection as a database attack technique. The end of line command means immediately, without making any prior work like this in tautology here, type in quotation, then or here equal to 1, immediately quotation, and then after minus. So there is no, I come back to the same example here. So here immediately single quotation, then command. That's it. Full stop. So immediately to try to retrieve the data here, validating that the username is nothing. So this is actually an end of line command. This is an end of line command attack. The piggybacked actually queries. It is a scenario via which the attacker passes more than the required command. Actually, it would actually clearly select, insert, update the queries from within the input point, from whether the username field or the password field. So it is a piggybacked, means it is a list of queries to be submitted. A list. It's a long list, maybe, to be submitted by the attacker from within the input point in order to try to tackle the capability of the potential of the database engine, because some of the status might cause to bring the database engine into a stuck state, blocked, not blocked but locked, cannot respond because he's baked for the queries. Depends on the pronunciation. Okay, any questions here, please, at this level? Great. So against those lists of, let's say, SQL injections, there are scenarios. There are actually, we cannot leave them like that. So, and do not expect to find a system that uses a database clearly vulnerable to a simple SQL query, a SQL injection. No, absolutely no. So they are by default having level of security, and then after the system owner, the developer of the system, would enhance more the security based on what? Based on so many techniques. So the access control is one of the scenarios via which we can deprive the access to the database entities. This is one of the very famous the access control. It's a very famous security approaches. They are deprived. As anybody tries to access, he is deprived. Cannot. Other actually security perspective, which is to assign specific rights to the users. Rights means to create, to insert, to update, to delete, and so on. All of them, they are different rights to be given to a given session or a given user, specific user. The data, like also the data access, it can actually be run based on the use of different security techniques, or security, let's say, policies. We may say that actually. It can be actually run on top of a centralized administration. There is only one central administration bureau, and the central bureau do commands all the users across the world. Central or centralized administration. Ownership based administration, which is actually if you are the owner of the project, so you are granted access. Otherwise, no. And the third one, which is decentralized administration, which is functions to be done on top of the database. There are many, and those functions, since they are many, they are going to be segregated across the users. Every user will take and will be responsible of a specific task. Thus decentralized. Thus decentralized. Yeah, I'll stop at this level and we'll discuss the in semester number 2 next week. Just if you hear your name, first of all, just say yes.